We have with us Mario Bollini. He is leading the Atlas product management team at Boston Dynamics. Hey, Mario. Thanks for joining the Humanoid Hub.
Of course. Thanks for having me.
So I wanted to start with your personal journey. How did you get interested in robotics? Any inspirations growing up? Can you walk us through some key moments in the journey?
Yeah. So in high school, did Science Olympiad and made a lot of Rube Goldberg machines. And when I wanted to go to college, I really wanted to be an engineer and to build things. So I studied mechanical engineering at MIT, and along the way realized that there's a lot more in the world beyond just the mechanical. And I wanted to study computer science and electrical engineering to kind of build this like toolbox that would allow me to work on all sorts of interesting projects. And robotics is kind of the intersection of all of these. And so in undergrad, I started to kind of concentrate in robotics, and then went back to grad school and worked on the PR2 robot doing autonomous cooking. And so it was an opportunity to kind of do long horizon planning, to do robots in a more unstructured setting. And after that, I went and did a few startups that were based on some student projects that I was working on. One made mountain bike wheelchairs. That company is still making wheelchairs for people with disabilities to go camping or spend time outdoors. Another company that I worked on was making plantable pencils, and I sold that to our distributor, um, who's making lots of plantable pencils in Europe now. And at the end of this startup journey, a friend of mine who was at Boston Dynamics reached out and said that they were thinking about commercializing Spot as the company's like first product, bringing their robot in the world. And I was excited to kind of join a company that had that ambition to define a new category and to take the world's best and most exciting hammer, this quadruped robot, and figure out the right applications, the right way to build a business and shape the direction that the technology would develop.
You have done a lot of work, like you said, with the Spot quadruped robot there, identifying opportunities and scaling the product revenue to over $100 million. So how was that experience, and will the learnings from that experience benefit the Atlas program?
Yeah, it was really exciting to kind of start off at the beginning with Spot's commercial journey, to set up an early adopter program, to figure out how people are using the technology, and then to eventually, carve out a niche in dynamic sensing and the kind of facilities maintenance and monitoring that we're doing now with Spot. And probably the most direct transfer to Atlas is we learned firsthand how large companies adopt new technology like robotics. And robotics is like so exciting. And if you bring a robot to a new customer, they're going to be really excited about it. And it's very easy almost to sell that first robot just out of excitement. Um, but that's actually a really noisy product signal. That excitement doesn't actually mean that the robot's adding real value per se. It just means that the person who happened to have a budget to buy a robot bought a robot. And so what we learned on Spot is, a robot is this digital transformation that's happening at a company, and you need a lot of people at the company to buy in, and they all have different goals and different requirements. And we kind of learned how to navigate the stakeholders as we went from these corporate innovation groups to these operator and maintenance groups that were really interested in keeping the facility up. And the robot just happened to be the best tool for that job.
Switching to Atlas, the original Atlas had hydraulic actuators. It showed impressive power and dynamic moments. But the latest one has the electromagnetic motors. Why was there a significant change in the actuation strategy?
Yeah, we kind of reached the point of convergence where like batteries became energy dense enough that you could power this in an electromechanical way. And our team started to design its own electrical actuators. We started to build and design our motors in-house to get the performance required to do this. And so, hydraulics had this great power density that made it possible to have a really athletic robot, but it was never something that we could bring out into the world. It's running at thousands of psi. It's really potentially dangerous to people around the robot. The floor always had hydraulic fluid on it. It was really kind of like a messy, hard to maintain machine. And so we knew that if we wanted to move to the next level of performance and eventually make a humanoid that could go out and be sold to customers, we had to switch to electric. We learned a lot about electric actuation with Spot, and we started to kind of leverage that at the next level with the first electric Atlas.
And the hydraulic atlas set the industry standards for dynamic locomotions also. So we saw it doing backflips and parkour skills way back in 2017 and 2019. And the new atlas is also able to do a lot of those movements and maneuvers. So how has the underlying training and control evolved between those two generations?
Yeah, that's a great question. So we, with the old Atlas, we're doing, kind of what we had made our name for at Boston Dynamics, high performance, more classical control approaches like MPC. And with the new Atlas, we started the design back, when we were still very much in MPC world. It was really going to be this advanced gymnast, and it's kind of designed as this Formula One car that is, way beyond the physical capabilities of the hydraulic robot. Along the way of doing that mechanical design, we kind of saw this paradigm shift into reinforcement learning techniques and, techniques like behavior cloning for manipulation. And so our team has leaned into that, and we have a number of partnerships with people like Ray or people like NVIDIA or people like TRI that we've used to really kind of jump forward to the state of the art with these new approaches. And our team has really been excited about how much of an accelerator this is. And so some of the latest releases you've seen from our Atlas lab and our Atlas videos, we're just getting started on that work, and the results are amazing, and we have some great things in the pipeline.
So are the latest techniques also making it easier, making it quicker to program a lot of
Absolutely.
the locomotion movements?
Yeah,
Mm.
for locomotion especially, the paradigm shift to RL training and creating these whole body policies has dramatically accelerated the timeline. I think in some of our recent videos with the robot crawling or doing that dance move on the floor, that was done much faster than if we had done it in previous approaches. And we're seeing even more of an acceleration with some of our manipulation policies.
Designing custom actuators and motors must have involved balancing a lot of factors, and Atlas is built for doing heavy duty tasks in industrial settings. So from product perspective, what were the trade-offs that you had to think about when designing the actuators?
Yeah, I think, the first big set of trade-offs was driven at cost. Robot that does heavy duty tasks is great, but only if it delivers ROI to customers. And we've been fortunate to have Hyundai as this, amazing test bed with many applications of humanoids in-house, but they also understand what it takes to bring a product to scale. And so we've been able to partner with them to figure out some of the trade-offs to make a really high performance machine at the right price. And then from a product perspective, we've helped our team understand, the set of applications that we want a humanoid like Atlas to do in the world, whether it's loading this specific type of part or taking tires out of a trailer or, moving debris at Fukushima or, any of the conceivable things you'd want a humanoid to do. And we can use our design tools to understand, how strong a hip motor has to be in order to accomplish these tasks, how strong a finger motor has to be, or what range of motion you need at a shoulder to do that. And so we can really kind of programmatically scope tasks and component level requirements from the set of applications that we have explored and evaluated on the product team.
One standout feature in the new Atlas is its ability to fully rotate its leg from the hip, so the whole robot can turn around in place without stepping its way.
Mhm.
So was it a deliberate design or product decision? And Are you seeing benefits of this feature in real world use cases?
Yeah, I would say it was a deliberate engineering decision. You know, if you take the ethos of the company and building this amazing machine that can embody this athletic intelligence and be, you know, a really capable follow-up to the hydraulic atlas, the design team realized that switching to electric would allow us to have much more range of motion at individual joints, including, you know, the knees and hips and torso. And you know that would open up a lot of product opportunities to accelerate tack times. For instance, if the robot could just spin its torso instead of taking steps, there's opportunities to speed up the cycle time and add more value to customers. And then from the product side, we've kind of leaned into that in the set of applications we're looking at to find applications where by switching to Atlas, you know, customers can lay out their work cells more efficiently. By switching to Atlas, you can eliminate lift assist devices and all of these downstream costs. And so, you know, it really kind of came from, you know, an awesome engineering capability and decision, but it's having a huge impact on our product pipeline by allowing Atlas to move faster than a person and not really limiting us to the human form of a humanoid.
Yeah, so that the kind of superhuman ability brings me to this ongoing debate in the industry about the humanoid form factor itself. Is it really an ideal form factor? Can we be more imaginative and go beyond human form? And then there is the other side of the debate, which says, do we really want such a complex form factor for industrial tasks? Is it really over-engineered solution? So where do you stand in that debate?
Yeah. You know, I guess going back to the beginning of the interview, where I studied mechanical engineering and then, you know, branched into software and electrical, it's really about where you want to shunt your complexity. And so for us, having a humanoid form factor allows us to turn the customer to customer requirements into a software problem. And the promise of humanoids is the generality that you get on this platform, which is especially important at early stages of productization, where you want to be able to find new market opportunities and iterate quickly and, you know, find the shortest path to value for customers. Like in the fullness of time, you know, maybe some of those first applications we do with a humanoid would be better with a robot with one arm or four arms or, you know, wheels on its feet. But having the humanoid form right now gives us kind of the maximum aperture from which we could evaluate the commercial opportunities of this advanced approach to manipulation. And as the industry evolves, I kind of hope we end up with robots of all different form factors and we can take our customer relationships and add value to them with different platforms.
And the customers that you approach for commercialization, have they um, have their skepticism changed about the humanoid form factors? What are the main hurdles that they want to cross so that you can do more pilots, more testing, more deployments?
Yeah, I think, you know, in every first customer conversation, we talk about the humanoid form and we got kind of go through this series of questions, but it really boils down to like, can the robot deliver ROI to the customer? Like robots are cool, they're a great way to get in the door, but customers want useful tools that add real value. And you know, pretty quickly in our customer conversations, we get to the brass tacks of the value that we can provide with automation, whether it's like direct value for doing the task or indirect value like greater uptime or introspectability or predictability or the ability to relay out a work cell in a more efficient footprint. Um, but yeah, once you get to the ROI conversation, the like shape of the robot becomes much less important. And then it's kind of on us as a business to take this customer relationship where we're adding value with automation and create a roadmap where we can kind of reduce the costs of delivering that value over time.
A lot of important vectors are converging, especially with rapid advancements in AI that we are seeing. Uh, what are what are some of the applications that you are most excited about in the near future? And what can you share about the the pilots that Boston Dynamics is doing with Atlas?
Yeah. Um, I guess like first, I'm just excited that we're at this stage in robotics where we're talking about taking a complex humanoid system and bringing it into the unstructured world. I worked on the PR2, which was an amazing robot, but it's not something that, you know, I could draw a straight line from that to, a robot in a factory or service industry or in the home. And so it's exciting to have these AI tools available to give us the like broad generalizability and to go after these tasks that are really hard to do in traditional like state machine or behavior tree kind of ways. Um, and there's just so much great research out there right now with robots folding clothes or robots in all these environments that we never really expected as quickly. Atlas is this superhuman machine that has an amazing strength as well as this amazing like versatility. And so we have been working closely with Hyundai to understand the material handling applications through their supply chain. There's lots of places where you either need lift assist devices or the work itself is really fatiguing or potentially dangerous. Handling tires out of a trailer or loading these like large pieces of sheet metal into stamping presses. And we're excited about, if you use a piece of automation like Atlas, how can you add short-term value, but then over the long term, kind of reimagine the process in that part of the facility. Um, we have a lot of spot robots at places like Fukushima that are helping people today, deal with these really dangerous and hazardous environments. Spot's an important tool for first responders. And a humanoid as a bimanual manipulator with a human range of motion is another like great opportunity to take people out of harm's way and use automation and tools like Atlas. We really see this as this like next level tool that's embodying this AI to help people do what they want to do and help companies deliver their goals. And yeah, this is really just the first step of a long journey.
You take safety super seriously, and there are many layers of safety, but purely from a technological point of view, are the humanoid robots ready to share spaces with humans and even do collaborative work with human coworkers?
Yeah, I think like safety is probably the biggest bottleneck that we're going to see as we see humanoids move from industrial settings into like service and home settings. And even from like a first principles perspective, like I have a toddler and it would be very scary for me to put a 170-pound human size anything next to him. And so there's a lot of intrinsic, safe behaviors that we need to design for. Um, Part of what we've done to kind of scope the problem for us at Boston Dynamics is to start in these industrial environments where we know we can add customer value with the capabilities we have today. And there are safety guardrails. You can have, train people around the robot. You can build safety policies that allow the robot to certifiably, detect people nearby, to respond in a safe and certifiable way. Um, and over time, as these techniques get more mature and as we develop uh, better sensing and compute, we can move these robots, closer and closer to people to the point where you imagine, the robots acting kind of in partnership with people. And so, humanoids are really like most economically viable in industry if they can go into all of these brownfield facilities and kind of work in these interstitial spaces where, having a KUKA arm with a cage around it, like it doesn't really fit from a ROI perspective or a footprint perspective. There's these like limitations with fixed automation. But a humanoid is this flexible automation. You can put it in, and you need to have a safety policy that allows you to act safely, to convince the factory that you're going to act safely, to convince the safety officer and the insurance company that you're going to act safely, and to allow people around the robot to really trust the behavior of the system and that it's going to be this safe tool that they can use. Over time, as we move into service era and home era robotics, like the safety stakes are going to get higher, but like that's going to be necessary for the field.
Atlas has a three-finger gripper hand. Can you explain the design and are we do we really need a five finger? Why not a five-finger hand for Atlas?
Yeah. So right now, Atlas is doing, the tasks that a robot like Atlas does best, like large, heavy object moving. They don't rely a lot on precise levels of dexterity. And so we chose to go with a three-fingered gripper so that we could maximize the strength of the robot, make the gripper as robust and reliable as possible, and minimize the cost of the system. Why make the customer pay for an extra 10 degrees of freedom that aren't necessary to do that task? And as we move into more general tasks, like you imagine general assembly, where the robot would need to use tools or do something really dexterous, we have opportunities to explore other gripper morphologies. Like a big part of our design philosophy is, figure out what's likely to change and make that as modular as possible so that we have room to upgrade over time. But it really does come down to like customer ROI. If you can deliver ROI with three fingers and make it more robust and cheaper, you don't necessarily have to tie yourself purely to the human form. But for some applications where you need that generality baked into the physical system, you might need a fourth or fifth finger.
Right. Boston Dynamics and Toyota Research Institute are doing joint work on large behavior models. So, what is that? Um, the term sounds very similar to large language models.
Yeah, so the thinking with a large behavior model is you kind of combine the world understanding of a large language model with the ability of a robot to move and interact with the world. And so we're starting to partner with outside firms like TRI to really explore the state of the art of different manipulation techniques, like behavior cloning or diffusion policies, to both give the robot more manipulation capability that you can access, programmatically, picking things up off the table or stacking them, but also as an eventual pathway to, getting to a point where someone can, be conversant with the robot. They can ground the robot behaviors in their language and have the robot actually do what they expect. For industrial tasks, this gives us like generality to go after many tasks in parallel at a specific customer. But for like service and home robotics, like this is going to be the foundation of all of the capabilities that would make those robots valuable.
And you're also partnering with Robotics and AI Institute, a
Mhm.
separate company founded by Mark Rabert.
Yep.
What is the nature of that partnership? Um, and also, why is RAI a separate entity while Boston Dynamics and RAI are quite aligned with the outcomes of the foundational research?
Yeah. So, it's we have been focused on commercialization for as long as I've been here, about 7 years. And as you focus more and more on like the tip of the spear, engaging with customers and delivering things that add value to them, it becomes hard to balance that in your head with really long horizon basic research. And so what we did is, our executive team and Hyundai spun off RAI as a separate entity so that it could focus on these long horizon, call them horizon three problems, the foundational breakthrough that has to happen to get to that next, uh, next wave of robotics, whether it's, in service industry or in the home. And in our end, we keep them loaded up with research problems that like we wish we could have solved so that our roadmap in 2 years checks out. And so there's this partnership and collaboration on this like middle layer horizon issues, but we don't want to bog them down with all the details of making sure the next software release for Spot or Atlas has the right features in it.
And what are your thoughts on the classic chicken and egg conundrum of robotics, where you need data to make the robots useful, but to get that data, you need a large robot fleet. So, how are you thinking of scaling rapidly to start that virtuous cycle, which is also very capital intensive?
Yeah, I think we have the unfair advantage that we have, thousands of Spot robots in the world. And so, if you're in a classical controls world, you actually don't need as much data to get started. And what we think about a lot from our product perspective is how do we build applications as stepping stones so that we can get a product, the robot and the software and the AI tools on top of it to deliver value today. And then by delivering that value, how can we expand the aperture, partner with customers to get data to train a next generation model and add more value? And so to use Spot as an example, industrial inspection and facilities maintenance is kind of the like bread and butter of Spot right now. And in the process of doing that, Spot's walking around, these factories and warehouses inspecting equipment. Um, and we launched a feature called Site View that allows it to do these panoramic views throughout the facility that help customers kind of see anywhere in their site. It's a visual digital twin of the site. Um, and that added customer value because they could see how the site changed over time. That also allows us to partner with customers to train custom detection models to do safety inspections live. So track if there's new puddles that form, new blocked fire exits, fire extinguishers that are out of inspection. And so like we added value, with Spot and this industrial inspection solution. Customers saw a quick ROI with that. That allowed us to have these robots walking around, which we partnered with customers to collect data and to train new models on that data. We could then add more value to customers by giving the results of those models to them. And then we can kind of snowball this. Spot environments are actually very similar to Atlas environments, and we hope that they'll share environments and we can start to use what Spot's understanding of the world is to inform some of the design and programming decisions for Atlas. And so, for manipulation, it's probably going to be a pretty similar trajectory where we have, Atlas on site doing certain tasks, and maybe we scope those tasks to something that we could train either largely in simulation with synthetic data or in a mock environment at Boston Dynamics. But once the robot is there and doing that task, we can create a training pipeline to do adjacent tasks and to lean on the diversity of the data set there. And so you really kind of have to like carve off these beachheads and make sure that they allow you to get to that next data milestone.
There is a growing interest in home use robots, you mentioned earlier. Do you think there is a viable path for the industry in general? And is it on the horizon for Boston Dynamics? And what are the most critical limiting factors that you see, maybe in passive safety or active safety, or reliability in general to get there?
Yeah, I mean, I would love to have robots be a part of our everyday life and to be in this like Star Wars world where there's all robots of different shapes and sizes around us. Home robotics present, really glaring safety challenges. How do you make this like large, capable machine also safe enough to use around your kids or pets or in your, fancy kitchen? How do you do that with a reliability that's baked in that is going to be acceptable to consumers? And then also like how do you figure out what people will actually pay for that? And so like we've kind of started in industrial because you have these affordances in an industrial environment that make the safety problem more tractable. It's a more constrained environment, so you can guarantee higher behavior reliability. It's a customer that's used to working with this type of equipment. And we're using that to kind of like get our sea legs and figure out, the dynamics of a humanoid business that will allow us to explore, service era, like restaurants, getting closer to the home, getting closer to interacting with people, and then eventually, step from there to home robotics. There are companies that are kind of going right into that space right now, and we kind of applaud them. But it's hard to define a new category, especially like directly with consumers. It's a really unbounded problem of like, what is your home humanoid going to do? How comfortable are you with teleop supervision? How often do you want to repair it? How do you build trust with the company and with the robot? And it's really early stages for that.
Boston Dynamics did some research on military use robots in the early days. But in 2022, the company signed a pledge for non-weaponization for Atlas and Spot. So can you talk about the ethical considerations and how do you ensure that your clients are not using it for weaponization or other unintended purposes?
Yeah. So when we were, getting ready to launch Spot, one of the like final button-up tasks that I had to do as the product lead was to write the terms of use. And uh, I'm really like proud that the like executive team and the whole company kind of stood behind this anti-weaponization pledge, and that were able to join with other robotics companies around that. And the reason for that is like fundamentally like this is a completely new technology. If we want robotics to have an impact, outside of industrial environments, if we want it to be in restaurants and homes and everywhere, people need to trust the robots, and they need to trust the companies that are bringing the robots to them. And in order to accomplish that trust and to get to the like big future of robots everywhere that we have, we think that the robots shouldn't be weaponized. And so we have in our terms of use really explicit conditions that prohibit weaponization of the robots or the use of them, to intimidate or harm people or animals. And we're lobbying our governments to enshrine that in law. We think it's really important that for robotics to achieve the potential we see, that people trust them.
The humanoid robotics landscape has been exploding, especially in last 2 to 3 years. There is a lot of new competition in the US and even more so in China. And with Boston Dynamics, with its legacy and lot of innovative edge, like how do you keep that innovative spirit while there is also a pressure to build a sustainable business as quickly as possible?
Yeah, I mean, we are racing to build a sustainable business as quickly as possible, and we're fortunate to have products like Spot and Stretch on the market that are a shorter path to doing that than humanoids generally. But if you look at the competition from China, like it's not happening organically. Like there is a national effort in China to bring humanoids, and we think that we need the same kind of concerted national robotic strategy here in the U.S. in order to have the level of cooperation to kind of bootstrap the ecosystem, to create the opportunity for American companies to compete.
Mhm. Looking farther ahead, maybe a couple of decades ahead, how do you see society and economy like transform with the widespread adoption of general purpose robots, and what role does Boston Dynamics want to play in that future?
Yeah, I mean, I'm excited about a future where robots are a part of our everyday life, and I hope that Boston Dynamics robots are, you know, ubiquitous. I think as as society goes through these changes, it's important to uh, teach people how to use this new technology as a tool. If you look at what we've done with Spot, bringing it to market, our philosophy was how do we make this as easy for the end users to use so that they can have the robot do something that they don't want to do uh, anymore. And so we put a lot of thought into like usability, understandability, trying to like create it as a really a tool that someone can use. And I think humanoids are the next level of tool. And so I hope that as robotics and approaches like AI become more commonplace, that people have the ability to approach them as tools and not as these abstract technologies that are just being forced onto them. That they can see that if you have an Atlas unloading tires from the truck, that's an opportunity for you to specialize in something else that's better suited to your skills.
And the last question comes from our 5-year-old. He's a big fan of the Atlas robot. He wants to know why is Atlas's head round?
Yeah, the team went through so many iterations on the head and of many debates about whether it should have a head at all. HD Atlas didn't really have a head, which made it really great for gymnastics.
Right.
We wanted Atlas to have a head because that is a huge opportunity for interaction with and relationship to a person. You can see, what the robot's point of attention is on. If the robot is going to approximate a human form, you want people to be able to relate to it. The team was really inspired by things like the Pixar Luxo lamp, and also wanted to kind of carve out something that was unique in the industry. If there's a lot of humanoid faces that are really just kind of like, Tron masks, and we wanted to like explore something else. Like, we are not Atlas is a humanoid robot, but it's really just a bimanual manipulator, and we wanted to like explore the design space in the same way that we have these hips that can turn and these continuous rotation joints and three fingers on our hand. Why limit us to a blank slate when you could have something that's a little bit more expressive and that kind of moves the needle in terms of how people relate to robots.
That's great. It's very exciting. Any last thoughts?
I guess I just encourage people to play with robots and understand them and, break apart that black box. And the tools to do that have never gotten more accessible than they are right now. And so it's a really exciting time and a really important time for people like in the country to kind of use those tools and realize that you can kind of build the future that you want. And so we're excited to build that here at Boston Dynamics.
Awesome. That it was great chatting. Thank you, Mario.
Yeah, thank you.